Welcome to Notes 3.4 for Algebra 1. This is real-world applications using linear equations. The goal for this video is for students to be able to apply everything we have learned in Unit 3 using linear equations. So question 1 says a swimming pool, when full, holds a certain amount of water. When the drain is open, the amount of water in the pool drains out at a constant rate. The graph shows the amount of water, W gallons, in the pool H hours after the drain is opened. Question A, find the vertical intercept of the graph and explain what the information is that it gives about the situation. So if you notice in here we have the word vertical or vertical intercept. This is something we haven't used before, but it does mean the same thing as the y-intercept. And so when it says to find the vertical intercept, it does mean to find the y-intercept. So if we look at the graph, we have 648,000. That is our y-intercept. The unit here is gallons. And so what information this gives for us is the pool had 648,000 gallons of water. Initially. Okay, so let's look at question B. It says find the slope of the graph and explain what information it gives about the situation. And so because we have a graph and not just two ordered pairs, we can just simply look at the graph and find the rise and the run. And so in order to do that, we should use exact points. So we already have one, which is the y-intercept. Let's look at another one. It looks like right here will work. So I've noted those in red. So what we would look for is the rise. We're moving down. It looks like 100,000. Be careful that it's not just 2. A lot of people would say that that is just 2 units. It's actually a decrease of 100,000, and because it's a decrease, it's a negative 100,000. So there's the rise. And the run, it looks like our run is moving to the right, so it's positive. It is not just 1, 2, 3, 4 units. It is actually, looking at the x-axis, it is an increase of 50. So your run is going to be 50. Okay, so in this case, the slope, finding the slope equals rise over run, or in this case, negative 100,000 over 50. And now because this is a real-world question, we are required that we label the units. So this was a decrease of 100,000, that is gallons, and it was in 50 hours. And so this will reduce to negative 2,000, and that would be gallons per hour. And so if we're looking to see what information this gives about the situation, it tells us that the pool is emptying at a rate of 2,000 gallons per hour. And notice that we did not put negative 2,000 here. The reason is we have the word emptying, and the word emptying will imply that we are decreasing. Now, even though the question didn't ask us to do this, I am going to write the equation for this situation. We have both pieces of information that we need in order to write this linear equation. We have m and we have b. Our equation would be y equals negative 2,000 x plus 648,000. And negative 2,000 means that there was a decrease of 2,000 gallons per hour, and 648,000 means that we started with 648,000 gallons. Okay, so let's move on down to question 2. Question 2 says, Jeanette rents a bike while visiting a city. She pays $7 per hour to rent the bike. She also pays $8 to rent a baby seat for the bike. She pays this amount for the baby seat no matter how many hours she rents the bike. The graph shows her total cost, C dollars, after H hours. So question A says, find the vertical intercept of the graph and explain what information it gives about the situation. So again, vertical intercept implies y-intercept. And if we look at the graph, we should be able to find that the initial amount here, the starting value, is 8. And hopefully we can see that that $8 is the initial amount it costs to rent the baby seat. So if we are going to explain what information this gives about the situation, we would say that this means she initially spends $8 to rent a baby seat. So she initially spends $8 to rent a baby seat. So looking at question B, it says find the slope of the graph and explain what information it gives about the situation. And so again, because we have a graph in front of us and not just ordered pairs, we can just simply find the rise and the run. In order to do that, we should use exact pairs, or exact ordered pairs. Looks like the first and last point would work. And so let's go with a triangle method and find the rise. Be careful of the scale here. It looks like we are increasing by 8. And so since we are increasing by 8, the rise should be 56. And then what we will do is find the run. And the run will go all the way across until I hit that ordered pair. And the scale here, be careful, it's not, it is by ones, but they're skipping every other line here. So we are looking at an increase or a run of positive 8. And again, how do I know to stop right here and not go any further up on the graph? If I were to go up any further on the graph, I would come across and not hit that exact point. So be careful where you stop when you're doing the rise or finding the rise and the run. And just to make sure we know how we came up with 56, it did end at 64 here. However, we started at 8, not at 0. And so the slope we know is rise over run. And because this is a real world situation, we will be labeling our units. The rise we know is $56. And the run is 8 hours. If you reduce that, 56 divided by 8 will give us $7 per hour. And so let's explain what this means in the situation. This means that she spends a rate of $7 per hour to rent the bike. And if you didn't catch on, you should have actually been able to answer these questions anyways, just based on the setup of the question. But we were connecting the question with the graph, and so trying to apply it to what we've learned so far in the unit. Okay, so let's look at our last question, number 3. Please make sure on the graph that you change the names to Anna and Michael so that it will match up with our question. Anna and Michael are salespeople. Each of them earns a fixed monthly salary plus an additional percent of the amount in dollars that he or she sells that month. So the total monthly amount, E dollars, a salesperson earns depends on how much in S dollars he or she sells. Question A, find the fixed monthly salary for each person. Well, since it's asking for the fixed monthly salary, it's talking about the initial amount that they each get paid to begin with. And so we can see that Anna makes $2,500 and Michael makes $1,500. And so let's write that down. Anna equals 2,500 and Michael equals $1,500. And again, because we were looking for the initial amount, we were looking at the y-intercepts for this question. So question B says both Anna and Michael earn a % commission. Who earns more commission? Well, to answer this question, we don't need to do any computations. We can simply look at the graphs, look at the line for Michael compared to the line for Anna, and the line for Michael is much steeper when compared to Anna's line, and so hopefully we're able to figure out that Michael earns money at a much faster rate than Anna, which means that Michael must make more commission than Anna does. And so the answer to our question, for question B, Michael earns more commission because his line is steeper, which we know means his slope was larger. Okay, so question C, it says to find each person's commission. And so since we're looking for the commission in this question, we're actually looking for the slope. And we know that the slope is rise over run. So M equals rise over run. So in order to answer this question, we're first looking at Anna. And looking at Anna's line, she is, looking at an increase of how many to start moving up this way. It looks like we're going by an increase of 250. This would be 2,750. Another 250 would bring us to 3,000. Move across here for the run. And the run looks like it is a run of 5. So we had a rise of a rise of 250 and a run of 5. And just be careful, we know that this is sales in thousand, so it's actually not a run of 5, but it's a run of 5,000. And so for Anna we have a rise of 250, and because it is a real world problem, we're looking at units, and that's dollars, and down here are earnings in dollars, and down here we're going to be looking at a run of 5,000. And so with the numbers we're looking at here, it might be easy if we use a calculator to calculate these values. And we have 250. So 250, if we go into a calculator document, 250 divided by 5,000. And if you would like to find the approximate or the actual decimal equivalent, hit Control Enter, and that should come up with 0.05. And so we're looking at 0.05, but the question is talking about this as a percentage. So that means that Anna makes 5% commission. And so she is able to keep 5% of whatever she sells. And so now let's find Michael's commission. Again, we have to find the slope. In this case, we're finding the slope of Michael's line. And so we have rise over run. Again, this is Michael. And so looking back at the graph for Michael, we have some options as far as ordered pairs go. We've already circled the initial value, or the y-intercept. We have another one right here. So let's find the rise and the run for Michael. Again, it was an increase of 250 per line, and so Michael's rise is a increase of 500. So his rise is 500, and the run is 2.5, or a run of 2,500, because again it was in thousands for the sales. And so Michael is looking at a rise of 500 and a run of 2,500. We're putting units here. And so again, if we go back to the calculator, 500 divided by 2,500. So 500 divided by 2,500. Control Enter should give us the decimal equivalent, and it looks like we have 0.2 or 2/10. And so we're looking at 0.2. And what is this as a percentage? We hopefully know that that is 20%. And so Michael makes 20% commission. And in case you were wondering what was going on with the units in dollars, the dollars will cancel each other out, and that's why we don't have any units on the answer in this case. That concludes video 3.4. Hopefully you have made note of any question that you were confused about or that you have questions about. Make sure that you go back and note those questions if you didn't, and ask those in class next time, and we'll take some time to look at what's confusing for you. Make sure also to leave a comment at the end of this video so that I know you've watched. Thank you, and I'll see you next time.